Hello and welcome to Autology, the podcast that brings you the latest on automotive technology.
My name's Graham Evans, Director of Electrification Technology Research at S&P Global Mobility. We're really excited to have NIO and ZF together today for Autology's podcast called Steering into the Future, Insights from NIO and ZF. One of the main reasons for this collaboration is that ZF recently started supplying the NIO ET9 with its steer-by-wire steering system. Many of you might have seen the recent video which lit up YouTube and automotive enthusiast chat rooms showing the incredible advances in road holding capability of the NIO ET9 versus premium sector competition. So we'd like to dive into this exciting development and explore how steering technologies are evolving. We have a unique combination of the automotive manufacturer NIO, the technology supplier in ZF, and then the S&P Global Mobility subject matter expert bringing an analyst perspective. So I'm really thrilled to welcome Danilo Teobaldi, Principal Chief Engineer at NIO, Stéphane Cassar, Vice President of Steer-by-Wire and Core Development at ZF, and Mengin Tao, Principal Research Analyst for Materials at S&P Global Mobility. Gentlemen, welcome. So I will kick things off with Stéphane. So maybe Stéphane, could you share a little bit about ZF's steer-by-wire system? What's the motivation really to move away from the existing electrical power steering systems, or EPAS as they're known, that maintain mechanical connections?
Well, thanks a lot and hello together. So indeed, steer-by-wire system is a game changer in the way driver interact with the driving, right, with the vehicle. It's all started with a combination of emotional targets and technical targets. Why that, right? Why and how this innovation in driving experience? So like you said, there is no mechanical link anymore between the steering wheel and the front wheels, which enables us to design a variable steering ratio by software. For the driver, what does it mean? We are adapting the steering response in real time to the car condition. So imagine yourself in parking, you hardly need more than half a turn of steering wheel to do the full stroke maneuver. And to the opposite on the highway, the system enables you to steer with more accuracy, with bigger angles, and it's all benefit for your comfort and safety. So it's not just a new system, it's really the enabler to the next driving experience through the steering wheel. That's the biggest innovation. But it's not only that, right? Innovation in cockpit design. Imagine you remove the mechanical connection between the cockpit and the cabin. It enables our customers to design new interiors. So it's innovation in interior as well. Of course, safety, when we talk about steering, is the essential part, and steer-by-wire enables to take the safety to the next level. We are designing systems which are based on redundancies. It means that every component, every sensitive component, has a twin which is ready to take over in case of very unlikely failures and keep the steering continuous duty. It means for the driver, continue to drive. So in a nutshell, that's steer-by-wire.
Understood. Yeah, good stuff. Thank you for the explanation. Interesting. Maybe just by way of follow-up, Stéphane, I mean, obviously we see plenty of examples in the automotive industry where some exciting new technology emerges and you start to see initial adoption in maybe like the premium or luxury segments, but then it kind of fails to cascade down into maybe more mainstream segments because either the cost is too high or consumer demand doesn't really mandate it. You know, we don't manage to achieve the economies of scale. So how does ZF foresee the adoption of the technology across the various vehicle segments?
Yeah, indeed, at ZF, we really envision that steer-by-wire will reach a broader market, including the mass market volumes. Because already now, what we can say, what we bring with steer-by-wire is that one set of actuators, because you have two actuators, one for the feedback unit, torque feedback unit, and one to manage the front wheels, you can equip all the models of the same platform. We don't talk about hardware diversity to equip all kind of possible cars of the same platform. One set of actuators can equip all the cars of a platform. That's the target, right? So it is also simplifying the way the car is designed, the way the car is assembled, and this brings benefits. So that's the first aspect. The second aspect is that we are building modular steer-by-wire elements that can be scaled up or scaled down. So as soon this will facilitate the introduction on broader markets. When the scale effect is there, it will be deployed to broader platforms.
Yeah, this makes good sense. Maybe it's a nice segue to bring in Mengin here to gauge his perhaps broader and independent perspective. So, I mean, Mengin, what trends are you noticing in the market when it comes to the adoption of steer-by-wire? Do we have a view on the technology? And also, maybe what's the S&P Global Mobility view on whether this will become kind of standard across all vehicles or whether it'll stay maybe more premium or more of a niche feature?
Indeed, after several years of engineering development and verification tests, steer-by-wire is now coming to the stage of marketing introduction global-wide. If we do not trace back the earlier or primitive application of steer-by-wire used by the brand Infinity and Toyota's Triumph on BEV platform, we see that Tesla started this round of installation of steer-by-wire system on its Cybertruck in mass production in North America since 2023. And NIO ET9 came in this March and became the first model with the regulation compliant steer-by-wire system in mainland China. And in Europe market, Mercedes-Benz is likely to be the next user of this system, either at the end of this year or in the beginning of the next year. So apparently we are approaching to the transition time from old to new. That is, to me, very similar with 15 or 18 years ago when EPS system has been replacing the conventional hydraulically assisted system for passenger cars. Based on our market research and forecast within a positive, very positive scenario, the global gross demand of the steer-by-wire system could go beyond 8 million units per year in 2032. And its share in leading automotive production region could hit close to 15% in that year. So in the long run, we see maybe within a 12 to 15 years forecast horizon, we believe there will be a substantial turning point at which steer-by-wire becomes a dominant solution for most of the automotives. But however, in this discussion, I would like to contribute some more influencing factors worth continued attention. This is also a very important factors we consider for our forecast. First of all, the regulatory compliance standards and the market entry certification might be roadblockers nowadays. The situation we are seeing is on one side, OEMs and the tier one suppliers are proactively pushing steer-by-wire to the market. But on the other side, regulatory authorities are relatively strict and prudent about the potential accidental rate caused by the removal of the mechanical connection. Certification tests and their acceptance have not been fully aligned. At least this is what we see in mainland China for the case of the ET9's steer-by-wire system entry. Secondly, we know that steering function is safety critical, right? And the redundancies for safeties are always mentioned. But on the other hand, we see that over redundancies will make the system totally unaffordable. Then we see from OEM side, right? Many of them are making a big investment on integrated motion control. This kind of concept can coordinate the primary steering function with other advanced chassis technologies, and all of which can contribute to a secondary steering function and guaranteeing degraded mode safety in case of failure. So all of this will be beneficial to the cost reduction and help the cost of steer-by-wire come to a parity with current REPS system. Furthermore, we also see the technical themselves are still evolving. It includes the higher voltage system, which do favor to the system efficiency and adaptability. But power supply standard belongs to kind of a platform design. We cannot easily expect a change from current 12 volt, 16 volt to 48 volt and above. That could be more preferable for steer-by-wire, can quickly happen for majority of the automotives. And in terms of the tuning of the steering wheel on a simulator instead of conventional road-connected steering column, it incorporates considerable numbers of objective data and subjective appraisals for OEMs who branded their product with superior handling properties. It will become a tricky situation to fully embrace the steer-by-wire system. And last but not least, a steer-by-wire system could be more widely and quickly used by the EVs, according to our understanding, rather than ICEs, since steer-by-wire can hardly provide additional benefit for the purpose of the fuel saving compared with a conventional EPS system. And according to what we see, steer-by-wire might fit better for larger segment vehicles which have higher front axle loads rather than smaller segment ones, on which a much cheaper column EPS can perfectly deal with drivers' want for steering functionality. So all in all, we are closely monitoring the technology changes from the industrial and the customer's attitude and the willingness to embrace this technology. So all of this compose a vital part in our forecast.
Thanks, Megan. Yeah, a huge amount to unpack there. Really, really detailed stuff. Really, really fascinating. I'm going to bring in Danilo next and get the ZF perspective. So, I mean, it's, Danilo, it sounds like ZF's technologies are kind of opening up the possibility of this, right? And opening up the design possibilities for car manufacturers such as yourselves. Can you share some specific examples of how this is helping at NIO, how it's shaping the design approach for a vehicle like the ET9? So what opportunities does steer-by-wire open up to the development team around, say, something like the package space or the crash performance? And perhaps what are the challenges when you try and integrate it in? So does this add to electrical complexity or some kind of system redundancy, for example?
Yeah, the general benefit of steer-by-wire, as was presented before, we certainly got most of them, all of them in the ET9. Specifically, we have realized benefit in terms of packaging and platform commonality. So not only ET9, but more of the NIO vehicles on the same platform will use steer-by-wire exactly in the same shape and form. We free up space inside the cabin because without the mechanical connection, you can actually enable certain functions like the stowaway steering, which at the moment, of course, due to regulation is either a level 4 kind of content, but in China is used also in parking mode when you can enjoy maybe watching movies or this kind of thing in the car, and having a steering wheel that disappears is beneficial. The design itself of ET9 is using a rectangular steering. This is to maximize the visibility over the infotainment, let's say. And is it possible because, again, thanks to the very aggressive steering factor that we can realize at low speed, basically you never leave your hands never really leave the wheel, and therefore a rectangular shape is at the end comfortable, even if it's counterintuitive from a traditional steering point of view. Obviously, there is a major advantage also in the driving experience. We mentioned again the very widely changeable steering ratio. So it's very comfortable in maneuvering, but is very dynamic, can be very dynamic in the mid-speed and can be very stable in the high-speed situation, which brings then the challenge and opportunity of the steering feeling that again was mentioned before. So yes, because of NVH and comfort, we want to filter the unnecessary vibration, but at the same time we have the challenge to stay connected with the road and deploy a natural feeling as a feedback, which again I think ET9 has been recognized as able to do so. Last but not least, there is all the software-defined vehicle attributes related to steer-by-wire, because it effectively open up even personalization and AI-based tuning, in case that is still an opportunity with the true over-the-air upgrades. And I would also like, as you mentioned, the safety, of course, it's an interesting advantage as well when it comes to crash management. Obviously, the main concern is how to manage the redundancy and the safety of the system itself. Is not just system. The system, as Stéphane has mentioned, has an embedded redundancy. But at vehicle level, of course, there is the redundancy in power, the redundancy in communication, and also the third layer, which has been mentioned before. So basically, with a steering wheel angle and the use of rear steering and the brakes, the car is still able to maintain trajectory, even in a case of a catastrophic failure of steer-by-wire, which is obviously very rare. For example, in NIO, thanks to the combination of redundancy and the third layer, we have a FIT, so failure in trillion kilometer, less than 4.5, which is extremely safe from an engineering point of view. So all of these are advantages and the main challenge of the steer-by-wire.
That's great. Thanks, Danilo. Yeah, I'm glad you mentioned MVH. It's a subject very close to my heart from my previous life. We'll come back to that shortly. Maybe let's go back to Stéphane. And I have this analogy in my mind where I think about, historically there was this transition from hydraulically assisted power steering to electrically assisted power steering, and this change kind of offered some benefits in things like fuel economy. But then there were compromises on steering feel and driver engagement, and certainly initially in some of these early systems. So maybe now the technology is prevalent across mainstream segments. It's improved, it's been refined, etc. But of course, there was an extra focus on safety with EPAS and what would happen if the electrical assistance was lost. So we've now got this situation where you could have like an electrical failure and you could have the absence of the physical connection. And I know Danilo has kind of alluded to some of the kind of redundancy that's been built in steer-by-wire systems. But yeah, could you speak maybe from the ZF side, what extra safety features are built into the system that would really give the reassurance to consumers that, could it actually be even safer than a conventional EPAS system?
So today on the conventional EPS, and not all EPS, right, you have already some redundant EPS systems. We are achieving a level of probability of fault which is extremely low, right? We have further developed that with the steer-by-wire because the actuators are redundant. It means that at the system level and then at the car level, a failure of any component cannot take you to a stop. You continue to use your car. The redundancy associated between the two actuators enables you to have a staggered approach in the way the system would keep managing its mission until taking you to a safe state, for instance, which can be a low speed state, for instance, where here on the NIO ET9, the third layer management at car level can also take place. So the level of fit that Danilo has mentioned is extremely low, and this is all benefit for the availability and the safety. So that's first thing. The dependency you have mentioned to the board net and the redundancy. I would like to correct something. You already have IC equipped cars with redundant board nets, especially the ones going to level 3 or level 2 plus automation. So we are not requiring any revolution here on the power net, right? We are using the redundancy of the power net, and it's done in combination between the car maker and the system. So the system is fail operational to some degree by itself, and we are bringing that to the car. But I like the analogy you made with the introduction of EPAS, because I was there as well, right? Way younger, but I was there, and it was so thrilling at that time because we had a lot of questions. You go to closed loop, but you are propagating the fault, etc. This has been managed, and this is a very solid foundation. It means all the use cases of a steering event, they are for sure the foundation of the steer-by-wire event. And the impact of steering the wheels is the impact of steering the wheel on the car, right? So we are bringing the system and the car to the next safety level. This is clear. Last but not least, the challenge of steer feel. Yes, okay. But today, with a traditional system, you absorb a lot of the energy of the front axle through the intermediate shaft to the cabin in the inertia of the steering wheel, which in the end brings some compromises to be made on steer feel, on-road feedback. With the steer-by-wire, thanks to this decoupling, yes, there are challenges, but it brings a lot of benefit because it's not just a matter of being more direct, it's a matter of being capable to isolate, filter, amplify if you need some frequential content, and then to design the steer feel that you want and to make it bespoke to the car, not to make it dependent on the balance, friction, inertia, geometry anymore. And we are working quite heavily, I don't want to disclose any secret here, to bring the steer feel back rather than to try to make a steer feel. So that's really the first step in the thrilling era of coming back to steer feel. Yeah. Maybe Danilo, you want to comment that on your car, because it's not just the steering system, it's the way to use it. And of course, it depends on the chassis design.
Yeah, I'll bring Danilo in here, and it was kind of jumped into the next series of questions that I wanted to pose to him actually, with some great answers. But it's great. It's really important, and this aspect that obviously steer-by-wire can boost driving comfort. This idea that you've removed a transmission path, but obviously one of the challenges of EV development, has been this kind of structure-borne road noise issue, right? You've got this inherently quieter cabin. You've got no engine noise to mask what else you might be hearing in the cabin because the engine's gone, right? And so does steer-by-wire help with this in the absence of a mechanical connection? Can you talk a bit maybe from the NIO side about what the trade-offs are in terms of that balance between refinement, ride comfort, and then the handling performance?
Yeah, certainly on the structural borne perspective is helping. There is obviously vehicle level. We need to take care of the other path because the steer-by-wire, the EPS part of the steer-by-wire is obviously still receiving input from the wheel. It goes typically in a subframe, and the subframe into the body, and eventually the body into the seat. But that's more a normal, automotive kind of NVH vibration suppression. Is not necessarily linked to the by-wire technology, right? The by-wire has added a layer of complexity in NVH inside the cabin because we have the torque feedback actuator, which is obviously an electric motor, gears, and so on, which bring the risk at a certain point of unwanted robotic noises or whining and so on. But again, is all manageable because it's not the only motor inside the cabin, right? You have in the seats, you have in many other applications. So in this perspective, I think is a slightly different approach, but inside the general capability of a quiet cabin. In the comfort versus handling, or let's say steering feel, natural steering feeling as opposite of isolated steering feeling, of course. Provocatively, I say that this preference might change over the years. People like me and Stéphane maybe are used to drive even purely mechanical steering without even the hydraulic assist. My daughter will not, and maybe the next generation will be so used to drive maybe simulators or games that they will not really appreciate anymore a refined steering feeling. However, of course, we are living in the present, so NIO, with the help of also our driving simulator and of course all the necessary vehicle and hours spent improving ground together with ZF as well, I think we have an excellent trade-off between the isolation needed by NVH, but also the feeling of being connected to the road and fully in control of what's going on, right? So yeah, I think that is the one of the key elements for the success of the technology at the end of the day in present term.
That's great. I think you bring in a really interesting point there that I wanted to pose to Mengen actually, and that's the fact that consumers are changing. We have this huge growth in vehicle ownership and EV ownership in China, for example, and this is an example of a new feature that you're right. You've got impressionable new consumers who maybe aren't burdened or have a perception of what the technology used to be, right? So maybe Mengen, could you talk a little bit about how do you see the importance of this feature to automakers and consumers in the Chinese market? I feel like we're learning constantly that the market is very different. What consumers want in China is quite different and quite specific to the rest of the world. And of course, the technologies are evolving very quick. EV adoption rates, significantly ahead of many other major markets. So do penetration rates for this type of technology differ in China? Is this something that you think consumers will particularly want or demand?
Indeed, as you know, that Chinese auto market becomes very unique now, with the highest take rate of the EVs around the world. In 2025, we forecast over 10 million units of pure electric vehicles, and over 5.5 million hybrid vehicles will be made from mainland China, where the market share of both of this kind of EVs is likely to surpass 50% of all new vehicles produced in this year. Meanwhile, we see that upgrades of the EA, which is electric and electronic architectures, are going really fast with a new car launched here. And most of the consumers here in China market respond very positively and proactively to the evolution of the ADAS and the autonomy features. Through some market research we have done in China over years, we can understand now that superior riding comfort with roomy space in a car is one of the most feature for customers in mainland China. Another interesting observation I would like to share in this occasion that toward this market is at this stage, we can still see a considerable number of new car consumers still have sort of pompous pursuit and like to show off high-tech specifications on their cars that used to be only applicable for luxury brand some times ago. So as a consequence, I would say Chinese domestic OEMs, including startup EV makers, are really intending to adopt advanced chassis technology to promote the competitiveness of their new car models. So all of aforementioned factors are creating favorable conditions for steer-by-wire's introduction into this market. But on the other hand, I would say we have seen something different, and there are also some kind of challenges for rapid growth of the steer-by-wires adoption. First of all, you must know that the market competition in mainland China is quite fierce and intense. After several years of huge investment and the price wars in the end market, in pursuit of a higher market share, more OEMs have set up targets for profitabilities. So cost saving and achieving the economy of scales becomes the top priorities in the next few years. And secondly, we have already seen lots of advanced chassis technologies flooding into the market, including what has been mentioned by other two guests, like the electromechanical braking EMB system, active damping, active road control, and air suspension system, and so on, right? So OEMs can hardly do them all at once. So they have to do some trade-offs in balance of the investment and to get some tangible benefit in return. So certainly the whole supply chain, according to our study in China, is yet to be fully ready for a quick volume ramp up for the advanced steer-by-wire system. From one of our research, we know that Chinese domestic supplier for steering systems are still way behind their global competitors in terms of the technological advancement and the reliabilities of the final products. So all of this lead to a kind of conflicting factors for certain forecasting in short and even midterm. So in China, so because of the complexity and because the market is quite dynamic.
Absolutely. Really interesting stuff. And I think that gives us a nice opportunity to bring back in Stéphane and Danilo, maybe for a kind of a final word, right? And this is all quite exciting when new technology like this gets deployed. Can both of you maybe speak to any kind of new further developments in the sort of chassis engineering and steering space that you think consumers should be excited about? So, maybe does steer-by-wire open up some new opportunities? And, what are the next major engineering challenges that relate to steer-by-wire as we integrate them into battery electric vehicles? So maybe Stéphane first.
Yeah, I think I would mention three points. As we touched today, the further development of this driving feel. I don't want to say steer feel or road feedback like in the good old days, but this experience, right, will continuously develop from now on, knowing that we can define it by software, by algorithm. So depending on the steering wheel shape, for instance, it would bring some new experience, and we will be working on that. The second point I want to mention is that we are software defined here. So we start to remove the mechanical compensation, replace them by software management, and it opens the door to the centralized controls, the chassis controls, where steering, braking, suspension would be all integrated. Now the steer-by-wire with the two actuators and the feeling can be part of it. Understand the reduction on the number of ECUs, understand better collaboration, or let's say next level of collaboration between actuators of the chassis for further performance, but also further comfort, like you mentioned. And the ride comfort is something coming very, very, very strongly. And maybe one step beyond, but having a digital connection between your interface or your HMI, right, human-machine interface to the steering, you can imagine that some new ideas of this interface could pop up, and they would use all the foundation of steer-by-wire with a steering wheel in the future.
Interesting stuff. Thank you. Maybe Danilo, anything to add?
Yeah, I think from smart chassis perspective, the NIO Skyride, which is our name for the chassis content of ET9 and the platform, has set a new reference line basically, and is recognized by the media and whoever was able to test the car, right? But we mentioned that there is an extremely competitive scenario. There is especially in China, we know that the steer-by-wire specifically will be applied in short term to other brand, and that means that the competition move from I have this feature to I am the best of applying this feature and give you the best possible performance out of this feature. At the same time, there are advanced technology, which NIO is also engaged with some study. Steering system, for example, the independent actuator. So at the end, you don't have a rack anymore, but you control truly each wheel by four single actuators. At the suspension system, of course, there is also the topic of hydraulic base or linear motor base active suspension, brakes. We mentioned EMB before. I see that everything is going in the same direction. Somehow the digitalization of the chassis, which brings then control, personalization, and everything. And for NIO perspective, this is also at the service of extending as much as possible the AD time, the time driving in autonomous mode. So if I say what happened in the next 5 years, I think it will be a diverging situation in which the flagship product desperately will need even more advanced technology, but at the same time, the technology that today are flagship need to become available in mass market perspective. However, all in all, is not new to the automotive industry, right? Is a trend that is cyclically. Well, I'm not sure how to say it in English, but it repeats itself when it comes to the automotive industry.
Yeah, it comes round and round, and it's cyclical, right? Yeah, absolutely. Yep, great perspectives, and thank you so much for sharing them with us. And yeah, thank you to the three of you for joining. That's all we've got time for today. A big thank you to all of you for joining Autology. Thank you to all our listeners for tuning in as well. We'd love to hear your thoughts on today's episode at our autology@spglobal.com email, and you can find out much more at autotechinsight.ihsmarket.com. Don't forget to hit all the subscribe, follow, and like buttons to stay on track with the latest Autology podcast, and we look forward to you joining us again in the next episode. Bye for now.